is IP Mohammed Matthew, and I have taken part in the Dare to Dream contest hosted by Microsoft. As a part of this contest, I proposed in building a prototype that has a walking stick as its main core component. The reason why I proposed this particular prototype was since I wanted to make a walking stick intelligent. It hasn't been done so far. So this was my first opportunity to work with the .NET Micro framework, and hence it kind of served like an ideal candidate for this to happen. I've designed has a mobile unit and the beacons. The beacon is a separate unit by itself. The mobile unit is the unit that runs off the .NET Micro framework. In this picture, in this view, pretty much you see the ultrasound mounted on the walking stick. But there's one more sensory device, that's the accelerometer, that is already embedded on the device kit. And why do we use the accelerometer? Accelerometer is pretty much used to validate or give more precise RSSI values coming off the zigbee unit. So at different configurations, RSSI values changes, and for the localization algorithm, this is required to home in to the precise value of location that the algorithm would predict. And now if we look on the board, you have the zigbee unit. Let me shine the light on it. And then you have the RS-232 connection, which connects to the ultrasound device that is the ranging unit that is mounted on the walking stick. So on a completed system, you would see the Meridian CPU that's underneath this board, along with the zigbee unit, accelerometer, and the ultrasound, all mounted on this one walking stick. And the form factors are pretty small, so all of them can be mounted on this walking stick. And thereby, this would be an intelligent walking stick. Now let's zoom in on the LCD screen, which is just a basic user interface that I developed for the demo purpose. Right now on the screen you have two parts, the top part being the alerts and the bottom part being the status or given off from the various sensors that is connected to this mobile unit. The first line on the status is pretty much the distance in inches that is got from the ultrasound ranging unit. It's pretty accurate up to a certain precise number of inches. So right now I'm standing away from the ultrasound, so it gives you a value of 67 inches. But if I come closer to it, there the value decreases, and so using that you can pretty much detect any obstacle in front of you. Then you have the accelerometer reading that's pretty precise or pretty sensitive, so it keeps changing, but it's calibrated. Since it is facing in the z direction to the g forces, it's configured for 2g. So you see the z value, the calibrated value for this particular orientation being 64. So it's fluctuating around the 64 value. And then you see a floppy sign that is pretty much saying that the SD media has been inserted into this device. Why I would be using the SD card? It's pretty much to store the alert values, which would constantly change, but the beacons would push this environment information to this mobile unit at different times, and these values might change not that frequently, but on a less frequent basis, so you can hold that data on a SD card. And then you see the blinking satellite dish. It pretty much says there's a solid connection between the mobile unit and the beacon. So whenever it flashes, it has lost that connection. So the mobile unit always pings around the environment to see if there's any beacon, and if there's a beacon, it homes in, and so you see that satellite sign solid during that intermittent connection that it can create. Since these are low power devices, these devices go to sleep, so you should see loss in connection at different times. But once a packet is sent, it's pretty reliable setting, so you could pretty much guarantee that the packet would go to the beacon and from beacon back forth. And so that pretty much concludes this. And before closing, I could reset the board, and that draws you back to the first screen that would show up, and a single tap would take you back to the screen that you are. Now next, let's go into the see how the beacon is set up. This is the mobile beacon node that has an extended antenna for extended ranges. It's still the XP 2.2 series, supports zigbee. This is the development environment which created those assemblies that were deployed on the .NET Micro framework on the mobile node. So from here you see the three couple of projects that I had created to manage this prototype development. One is the walking stick prototype project. Then there's the device drivers library project, and then there's a zigbee library project. The device drivers pretty much for the ultrasound ranging unit, MaxPortix EZ1, the accelerometer on the device solutions board, and the SD card device driver. Then there's a library set for the zigbee, the XP module, which communicates with it via its API format. And for the scheduling, I had used threads, and this is a part of the snippet that is shown on the screen. So that concludes the software component of this development. Now I'm at the beacon. I'm going to start up the application that I wrote to send alerts to the mobile node. So that's starting up. You have the progress bar. It found the mobile node, the walking stick. I'm going to set up some alerts. Let's say heavy traffic. That is high. And then I have some construction ahead. Could say that is guarded. And then I could send this alert over to the mobile node. So that came back successful. Utilizing this particular prototype, I have to implement three more components to make it commercially competitive and successful. One of the main components is the localization engine that is development in progress, and it needs to be ported to the .NET Micro framework. It has been tested on other platforms, but for this platform it needs to be ported and tested. How does this help? It helps in identifying which is the closest beacon, and also identifies where a particular mobile node is in a particular space. Prior to this, most often you would use three access points, or three beacons are required to actually triangulate to a mobile node. In this case, we are trying to use just one access point because the nature of this design entails that you need at least one access point or one beacon to make this platform work. Then the second ingredient is the power saving feature that needs to be implemented into the mobile unit. So this makes it efficient and can be so that the mobile node can be used for an extended period of time. Last but not least is the management tool that would help in managing the beacon nodes and the mobile nodes. So once these three features have been implemented, I would surely say that this is a platform that can be it's commercially viable and would be successful utilizing the .NET Micro framework.